Okay, so today's session is going to be on using deep learning for traffic signal detection, right? The idea is we will learn the larger foundational elements of reinforcement learning, which is one of the latest cutting edge technologies that is transforming the world. And we'll also look at an implementation. Obviously, we'll not dive into the very core mathematics, but we will definitely understand the core ideas behind reinforcement learning, how it gets implemented, and we'll build a deep neural net using PyTorch to solve the problem of traffic signal detection. I hope everyone's ready. Can we get started? Guys, yes, no? Awesome. Thank you. Now, so when you talk about any kind of problem statement that is non-deterministic, what do we mean by non-deterministic? See, when I say 2 plus 2, you know that the answer is deterministic, right? It can never be anything else other than 4. The answer will remain same no matter at what point of time you do the calculation, at using what computer you do the calculation, using what library package you do the calculation. But in real life, most situations or problems are statistical. That means they have a component of randomness or a component of error that makes them non-deterministic, and the answers are not one short answers. There's no single answer to that problem. The answer could vary between a certain range, which is the composition of the random error. So today that we are going to look at is an advanced version of a statistical problem, which is detection of traffic signals. Okay. The idea behind this problem is that, first of all, this is just a single component of an autonomous vehicle solution. For example, companies like Tesla, when they are creating a automatic and humanless car, right? Driverless car in the technical sense, they have a lot of these individual components simultaneously making decisions to maneuver the car in a certain direction, right? We want to know how to manipulate the speed. We want to know at what angle to keep the steering wheel. We want to know when to brake instantly. We want to know how to estimate the speed of cars or vehicles in front of us, right? This is a small problem in a very large context of autonomous vehicles. So traffic signal recognition plays a crucial role because that makes sure that we abide by the rules, right? A very fundamental solution could be, let's say, whenever you detect an object in front of you, you press brake or slow down, right? Which is a very hardcore problem, and it's a very brute force solution to that hardcore problem. The idea is, if anytime you see an object, you stop, right? Then you might actually be stopping after the traffic signal, right? After the zigzag line, zebra crossing, okay? We want to detect signal, traffic signal, and use that as an input to brake as well, not just object detection. So we follow the traffic rules, right? Human drivers rely on visual cues, whereas driverless cars have to rely on detecting where the traffic signal is. First of all, you have to detect where the signal or signboard is. Then you have to understand what that signboard or what that signal says. Okay, so we need a accurate real-time traffic signal recognition system. And that is very critical because, first of all, you need a lot of data to train the model. And then you have to also use it in context of training reality. See, it's very easy to do something on paper at an academic level, but it is very different to have that in reality and the model, the robot or the machine to act in reality. Okay. What solution or technology helps us in that? So first of all, most of the AI technologies that you might have heard of, let's say ChatGPT, okay, or any other kind of predictor, they are mostly software solutions, right? Basically data code, something like that, and you get your job done. But here, in a very real life scenario, you are not just dealing with softwares, you're also dealing with hardwares. For example, in a driverless car, you can imagine the number of sensors, the number of data collection points that need to report the result at the same time. And the model has to make a prediction looking at all components and then taking a decision in real time. Does everyone understand this problem statement? Yes or no? Guys online, yes or no?
Yes, sir.
Right? So there has to be a hardware system and there has to be a software system, and they have to be in synchronous decision-making process. If I get the hardware input now and I'm taking a decision 2 seconds later, this could be a life and death scenario. Okay, that is why autonomous cars are expensive, because the amount of sensors they have and their data transfer speed, detection speed, their lag of passing information is very, very small. They instantaneously process the data and transfer the information. So any model, any neural net, any machine learning, AI, RL model that you develop to solve for this case should also be very, very fast. Because again, it is a life and death situation. Okay. So self-driving cars are on their own an autonomous decision-making system. The inputs come from LiDAR units, radar sensors, cameras for images, sound detection, right? Then there is the entire area. You might have seen that the expensive cars today actually have an entire monitoring system where you can view the position of your car, right? You can actually, while sitting on the car, check out how much distance exists between the left-hand side lane and your car's body. When you are, putting the car on reverse gear, you can actually look at the entire range of motion possible for the car. These are the simplistic implementations. A much more complex implementation is actually done when you do the same thing for autonomous vehicles, right? So multiple sensors, first of all, they give data in different formats. Cameras are going to give you images and videos. I mean, a video is basically a collection of images played in sequence, right? If you take a video, you can actually it's like a screenshot, right? If you take 1 second screenshot, every 1 second you take a screenshot of a video, you will get it in images format. So that's what the camera reports. It reports images in sequence, and the sequence is important, right? If you do not pass the sequence in the correct order, then also the decision making will be wrong. So the cameras have to provide image, which is basically in numbers, it's the pixel values in a sequential order at a very fast speed. The data quality has to be high enough so that the model can make better decisions. And then there could be other units that basically do a laser transformation, right? There is a laser that is being sent out of the world. If that laser hits a particular object, it returns back to the sensor. And the time it took to come back to the sensor actually tells the sensor what is the distance to the next object, right? For example, if it goes still, if it does not return for a long, long time, the car sensors know that there is no object for a long, long distance. But if it immediately returns the signal back, that means that there is a object or there is a restriction of some kind in a very nearby distance, right? So, and after all of this information in different formats, they have to be first brought down to the format required by the model to make a prediction. The deep learning model is actually a neural net, which actually takes numbers as input, right? So the camera images actually have to be transformed into numbers, which is the pixel numbers. Then the radar sensors, etc., will also be fetching the numbers, and then all of that will actually go into the main computer of the autonomous vehicle, and then a prediction will come. Predictions could be to increase, accelerate the car. Predictions could be to deaccelerate the car. It should be to brake, stop, turn right, turn left, turn right by X degrees, turn right by Y degrees, take a reverse gear, overall change the speed of the car, fix the speed of the car, observe the lane that is there on the car. All of these individual systems are constantly working to make your your journey in the car safe. Are we clear, all of you? Did everyone understand the problem domain, the decision space?
Yes, sir.
Okay. Now, what is the primary, very efficient solution for this problem? So think about it. How do humans learn? Humans learn by making mistakes. Does everyone agree? Yes or no?
Yes.
Okay. Now that definition is a little different. Okay. See, when we take a right decision, we did not make a mistake, let's say. We also learn from that. So humans don't learn just from mistakes. They learn from the output of their actions. Does that make sense?
Yes, sir.
Right? So this is a very common logical explanation that everyone should try to grasp and absorb. You will see that if you want your dog to be trained, how will the trainer train the dog? They will indicate to the dog that take this kind of action. For example, when we say sit, the dog sits down. When the dog sits down, we don't just stop there. We give it a treat. We give it a reward. What does that reward do? The reward simulates a positive feeling in the dog. The dog gets happier. They have been given some reward, something that tastes well, something that is, something that they wanted. So what you are doing is you are forcing or kind of reinforcing the dog to take a certain decision or to do a certain action again and again. Why would they want to do that action? Because you are rewarding them for that action. On the other hand, if the dog does not follow your instruction, does not follow your command, you do not reward the dog. Or you might even shout on the dog, or you might become upset and not talk to them. That gives the dog a negative reward, a negative feeling, right? So the dog understands that this is something that I should not do because my owner, my parent does not like this action, right? Now, it might be a little weird, but this is not just for dogs. Humans also behave the same way. Although we have the intelligence of recognizing situations, right? Because we are not stupid. I mean, our brain capacity is more than dogs or any other animal. We have senses where we can actually understand any kind of reward system. For example, if you go to the gym, right? Obviously, you are in pain. The reward that you are getting is not immediate. You will get a reward after a long time. But if you go out with your friends for partying at a club, the reward that you get is immediate. You are feeling happy, right? So talking about the concept of reinforcement learning, there is also a concept of immediate reward and delayed rewards. Immediate rewards are something that we do seek as humans, and the machine or the model will also seek. But delayed long-term or large rewards are something that actually are more valuable. Does that make sense, everyone?
Yes, sir.
Okay. So the entire idea is reinforcement learning is a way to replicate human-like learning. It is inspired by the concept of how humans learn. That is why you will see the names are very significant. What is the first name? Environment. What is this environment? This environment is the location, the place where the human exists. Okay. I am in an environment. Like we say, we are born in an environment. Okay. Suppose the office space, what is it? It is an environment. Depending on the environment I am in, I will take some kind of action. So who am I? I am the agent. Okay, this agent could be a human, could be a dog, could be a machine. It is basically the entity that has capability to do something. Okay, so the agent within an environment takes an action. Okay, it takes an action. Now this action is completely unguided in the beginning. That means if you take a 1-year-old child who has never seen fire in his life, who has never experienced fire in his life, he might actually go very close to the fire without realizing the harmful effects of fire, without realizing the fact that he might get burnt. Right? Guys, everyone agrees?
Yes, sir.
All of you? Yes, no? Okay. So in the beginning, any and every action is unguided. That means whenever I'm taking an action, I'm just taking a random action. What is that action? I am exploring my environment. So in reinforcement learning, it is called exploration. So what I'm doing is I am exploring the environment that is available to me. Okay, so I'm taking random actions in the environment. When I take the action, my environment reacts a certain way. That reaction is basically either a change of my state, okay, my current state. For example, if you take a robot and it takes an action of putting the left foot forward, then that means the current state of the robot has changed. Okay, if you take a child and its current state, let's say, is an empty stomach, and then the child takes an action of eating something, then the next state or the changed state is the stomach being full or having some food in it, right? So based on the action that the agent takes, the environment responds with a change in state. Okay, along with the state, it also gives a reward. What is that reward? Either it is a positive reward or negative reward or no reward. For example, if you do something and you do not get anything in return, right? You're not being belittled, you're not being disrespected, but you're not also being praised, you're not being respected. So that activity for you is a no reward situation, right? It's like a no profit, no loss situation. Okay. For example, just checking stocks, right? In the stock market, you just go and check stocks. No profit, no loss. You've not invested your money till now, right? You've taken an action. What is that action? You went ahead to the website and you are checking stocks. So that's an action. But there is no change in state. There is no change in reward. You can say there is a change in state by you knowing more about that stock, but there is no reward because neither have you won, neither have you lost any money. Now, if you get a positive reward, what does that tell you? It increases your inclination towards that action. Why? Because when you took that action in the past, you got a positive reward. Okay. For example, if you invest in a stock and you get positive returns on that stock, you will think that that stock is a nice stock because I got positive reward from it. On the other hand, if you invest in a stock and you lose money, you will think that the reward was negative and I should not invest in that stock because it is already making loss, right? Action and the reaction to that, the agent actually learns from this. Based on an action that the agent took, the reward that the agent got actually changes the state, changes the learning of the agent. If you know by doing something, you will get a reward, you will do more of that. If you know that by doing something, you will not get a reward or you will be punished or penalized, then you will not take that action. This entire process over multiple times, over multiple iteration, helps the agent understand the environment and how it functions. So now when the agent has learned the pattern, has understood the entire environment and how it works, it will make sure that it takes more actions that lead to positive reward. So it will try to maximize reward. See, reinforcement learning is a type of machine learning where agents learn by interacting with an environment to maximize rewards. Okay, so pretty long explanation of a single line, but I hope everyone is clear about it. Guys, yes or
Sir,
no?
sir, here rewards is the feedback. You want to say?
Yes.
Okay.
Okay. Reward is the response, the reaction to action, the feedback to the process, whatever you'd like to call it. It is what the environment gives you back when you take an action in it. Is that clear?
Okay, okay.
Now, this creates a very interesting challenge. See, now if you think that the solution to autonomous vehicles is to actually just create cars with that system and ask the cars to randomly take decisions on the road, how sensible does that sound, everyone? If I have to start with a randomized action that my agent or my model is going to take in an environment and wait for the reward to actually do the right thing, right? And it will take a lot of training, it will take a lot of time. Imagine how many decisions that you take wrong even today. It will take a lifelong of learning for you to have the perfect decision-making capability in your life. And reality, like your life, is statistical. That means there are a lot of factors that you can't even account for, right? You are prepared to go to office, you've gotten up on time, you've ironed your shirt, you've prepared the PPT that you have to present today, you have booked a cab, everything is smooth. Now before going to office, the cab service says that there is no car available. So everything that you could do was correctly done, but something that is external, that is out of your control, goes wrong. This is possible in autonomous vehicles also, right? Your agent, your model might be driving the car absolutely perfectly. But if another human being, human driven car actually comes on the road and, just hits your car, then it's not your fault, right? But that could still happen. So this takes a long time to train, to be in the environment and learn this entire system, and it still could go wrong. Okay. So can I start with randomized decision using a real car on the road? Do you guys think that is possible?
No, sir.
Obviously not. I cannot have a car on the road that is randomly taking decisions, because obviously the random decisions would lead to chaos on the road. Okay. That is why reinforcement learning is very interesting, because instead of a real environment, I can actually simulate an environment. Okay, I can simulate an environment. What does that mean? You might have actually seen a lot of robot training videos. I'll give you an example. Okay, robot training video using reinforcement learning. If you go to videos, let's say, I think images, maybe we'll find something good. See this. Here, the robot, this entire situation has been simulated. The robot is not actually doing things. It has an entire simulation. See, this is a robot being trained how to fight. Right? This is a robot being trained how to keep balance. This is a robot learning how to throw something. Right? So robots can actually be in a situation where the environment is simulated and the robot constantly takes action. It keeps taking action And if it is subscribing to the reward of the system, it will improve that. If it is getting a negative reward, then it will change that behavior and take a different course of action every time, right? So robot learns to walk, reinforcement learning. I'm looking for a GIF that will help us. Okay, a lot of money, resources, efforts, technology is actually going on to just build this system. Okay, just build this. See, in this particular case, an entire environment is being simulated, right? Intelligent locomotion. Again, you see deep reinforcement learning. An entire system is actually being simulated so that the robot learns to interact with the system, and over time it improves. After a lot of training, lot of learning from the environment, getting rewards back and forth, it learns, right? So the idea is, in reinforcement learning, what we are doing is, our job is to simulate an environment as close as possible to the real environment, and then train a reinforcement learning model, a RL agent, that interacts with the environment, gets a feedback, response, or reward from the environment, and adjusts its knowledge of the world using that knowledge. Is that clear, everyone? The entire concept of reinforcement learning.
So, is reinforcement learning based on permutation and combination of the decision making?
No, it does not act like that. If
Okay.
you actually figure out the permutations and combinations in a realistic environment, you will not be able to imagine the number of actions it can take. Suppose you are sitting in a car, okay? You have, let's say, 10 units of speed. Obviously, speed is more precisely controlled. So suppose 0 to 100. And I give you an option that you can increase either 1 kilometer per hour at a time or decrease 1 kilometer per hour at a time, like that. Okay, I mean the acceleration or deceleration speed I give you. So there is 100 possibilities of acceleration. Then you can move right, left, you can move forward, you can move backward. When you move right, left, you can move by 5 degrees, 10 degrees, 11 degrees, 12 degrees, 15, 20, 40 degrees, right? Then while doing that, you have to observe the traffic lights, right? There are so many possible decisions that can be taken at a single time. There are so many options that permutation combination fails. That is why we go with random initialization. We start the process by doing random actions. Is that clear?
Okay.
Okay. It's not like either buy or sell a stock where there is only two actions, right? I mean, talking in terms of autonomous cars, if you are building a automatic trader, I mean, autonomous trader in the stock market, then obviously your action will be buy or sell. But then also it will be how much to buy, right? How much to sell. Then it will be time at which to buy, time at which to sell. So many different decisions come into picture. Okay. Any other questions, guys, before we move to the next slide? Okay. Now, so there is an undefined driving situation, which is something like this. There are inputs coming from the camera, other sensors, GPS, etc., vehicle state. I know how much petrol I have. I know what is the current position of my steering wheel. I know what is my current speed. Okay. I know how much time it will take for me to brake. Absolutely. I know the traction between my tires and the road. I know my braking ability. I know my the distance that my car has traveled. I know the air pressure in my car. There's so many inputs that are present. This entire input actually goes into the reinforcement learning model, into the network. Okay. Now this network can come from multiple places. Imagine Tesla. Do you think Tesla is a technology company? What do you guys think? Is Tesla a technology company?
Yes, sir.
That's not true. Is Tesla a manufacturing and you can say automobile company?
Tesla is a innovative company which brings
Innovative is a fancy
new
word.
innovations in every form.
No, but innovation is a very fancy word. Okay, I mean,
Yes, sir. Automotive company.
okay, so that's also incorrect. Tesla is actually a data company. That's what a lot of people fail to realize. See, Tesla cars being sold all across the world are driving on the road with different conditions, different traffic possibilities, different types of drivers that sometimes drive the car, sometimes driverless, different kinds of traffic signals it sees. Imagine the amount of data that Tesla collects every day and the amount of improvement it can do. See, humans don't just learn from their own experiences. They also learn from other people's experiences. In this case, other people are millions of cars all across the world actually running on the road, right? So there could be a large model that has actually learned driving as a skill set. Okay. Then there could be a specific model that has learned driving only in that particular country in which the car right now exists. Then there could be a model that actually is only specific for that state in which you are driving a car. Have you guys realized a lot of people say that driving in, let's say, Mumbai is different than driving in Delhi, and that is different than driving in Kolkata? Do you guys think so? Yes or no? Not a major significant difference, but there will always be a difference in driving. It's just a city by city thing, right? How many rash drivers are there? How much traffic is there? What is the size of the roads? What is the population of that city? All of that defines the driving ability and driving quality of that city, right? So that is where these different models are actually playing a role. These different models are created considering different scenarios, different meta scenarios, and these models respond in output, which is steering, acceleration, which way to go to, what is the cost that is going to take, what is the state of the vehicle, the new state of the vehicle, right? So the agent is interacting in the environment, collecting rewards, positive or negative rewards, going to the next state and doing the same thing all over again. Over time, it is updating itself to access more and more positive rewards and less of negative rewards. How does this work? For in reinforcement learning, this particular technology or algorithm is called the Q learning algorithm. The Q learning algorithm actually does this entire, taking an action, getting a reward, and updating the model's learning, updating the parameters of the model to take a certain action. For example, the first time let's say, ate a lot of chocolate, right? You got a positive reward. The second time you ate a chocolate, you again got a positive reward. You kept eating chocolates for more and more positive rewards. But one day, because of eating a lot of chocolate, you had let's say you had some problem in your teeth, right? You had to get your teeth removed, etc., etc. The negative reward of that day is actually much more than the positive rewards that you have gotten over the years by eating chocolate. Does that make sense? All of you? Guys online? Yes, no? Right?
Yes, sir.
So the Q learning algorithm actually has the potential and context of doing this. The algorithm understands that I am looking for rewards, not just in the short term, but also in the long term. So a long-term reward of a large quantity might actually be prioritized over a immediate short-term reward. Small immediate short-term reward would be much less then large delayed long-term reward, which is the concept of delayed gratification. Okay. So that's the idea behind the algorithm. So this is just a summary of all the things that we've talked about. Traffic signal recognition is vital for successful deployment of autonomous vehicles. It is very essential for intelligent transportation systems. There are different deep learning techniques and algorithms in reinforcement learning that enhance the ability of models to take better decisions. Today, we will be taking a PyTorch-based model approach, which will just be doing a very simple task. Obviously, creating that model, the big actual autonomous model will take an entire GPU, compute resources. It will take millions and billions of data points, right? But we want to show a demo of how a single component actually works. Okay, so we will be using PyTorch, and we'll be using PyTorch to create a classification model that, depending on the traffic signal regions, it says stop or go. This technology obviously has real world implications. It is a part of the larger problem of autonomous systems. Okay, so let's go to the code. If you see, first, your data can be of different formats. Okay, if you see the training data, right? In the training data, you will see there is a file name. Obviously, these are generated by sensors and systems. Okay, so this is the file name, this is the size of the file, this is the attributes of the file, region count, region ID, region shape. Okay, what is the box in a particular? So remember, in the PPT we saw that at any point of time, what is this? This is a rectangular view that the camera has. Okay, this is the rectangular view. Region shape attributes and region attributes, stop or go. So this is the training data. This is where, let's say, a real driver was actually driving the car. Okay, he was looking at the signs, he was looking at the symbols, he was looking at his own eyes, which is the camera for him, and he was either pressing deacceleration or he was pressing to accelerate. Okay, using this training data, first of all, I'll just load this entire data. Right, I don't need things like file name. File name does not impact my decision. File size does not impact my decision. File attributes does not impact my decision. Region ID and region count also do not. Okay, I am just concerned about the location and the width and the height. Okay, so these are my attributes that will help me understand if I should go or stop. Okay, so I've just created a Python function where you process the data in a certain manner. And then I have taken the training file and the testing file separately. I will train my model on the training data, and then I will test it on the testing data. So this is what my data looks like. It has real information. So you might be thinking that all of this is, somewhere complicated, somewhere difficult, but truly, in the end, all models have something like this inside. These models have some numbers as input, and it has to predict some value as the output. Okay. So this is the output, stop or go. We will convert this into numbers for a machine learning model or deep learning model to train on them. And this is the input, the X, Y, the width, and the height. Okay. I pre-process the data where if my region attribute is stop, I will put it as 0, else I will put it as 1. So 1 for go, 0 for stop. Okay. And I will append all of this, the row X, Y, width, and height into the state. Remember, we are doing reinforcement learning, so there is a state of the system, right? And this particular entire step, this is not random numbers. This is actually a sequence of numbers. So I was in this state, then I go to this state, then I go to this state, then I go to this state. So normally there is this concept of connection in the data and disconnection in the data. For example, if I give you loan accounts of 100 people and I ask you to predict how many of these loans will default, that means how many of these people who have taken a loan from my bank will default on their loan payment. Each individual file is different. Is that correct, everyone? Yes, no? Is that understood?
Yes, sir.
every single file that I view will be independent of each other. So while analyzing a particular file, I will make sure that I treat all of them independently. Decision of one person defaulting the loan should not affect the other person defaulting the loan, as obvious as that sounds. But in this case, these are frames, one by one, one by one. They are sequential. It's like time series. Every single point can actually be associated with a timestamp, and that timestamp defines the order in which the execution is conducted. Right? So the order matters. That is why I'm putting everything in a states list. The state list basically takes the row X, Y, width, and height. Okay, these are my states, these are my targets. Then I create a PyTorch model. In PyTorch, it is the way neural networks are created is from torch.nn, you import nn, which is short for neural network. You also import the optimization functions, and then you have a DQ function. DQ function actually helps you understand the sequencing, the order in which the data is passed. Okay, so I create a very simple neural network. Okay, it basically abstracts from the neural network module, and then it has two layers. The first is the linear layer, the second is also the linear layer. There is a hidden size. I can change the hidden size depending on the complexity of the data I have. There is the input size, then the hidden size, and finally the output size. The data that I get, I pass it through a fully connected layer. FC1 actually means fully connected layer. So FC1 is the fully connected layer 1. FC2 is the fully connected layer 2. Right? I pass my input data through the fully connected layer. Whatever I get in return, I pass that through the fully connected layer 2, and this becomes my forward propagation in my neural net. Okay, this is my input size. I am defining the size of my hidden layer, and I am also defining the output size. Output size is 2y. Either I'm going to predict stop or I'm going to predict go. I could have actually predicted only a single value that could be treated as probability, but I am actually outputting two values, which is 0 or 1 or 1 or 0 for the two placeholders. This is where I have created my neural net. Okay, I have actually instantiated my network. I have said that use cross entropy loss as my loss, or basically as my error term, and use Adam optimizer to optimize this entire network. Okay, I am using float tensor to convert my states into tensors. Tensors are what actually act as input to the PyTorch module, and long tensors for the labels, which is the 0 and 1 integer format labels. I will train this entire system on this entire data 1000 times so that it sufficiently adjusts its weight to make the correct prediction. And I will make updates on a batch size of 32. So number of epochs means number of times the entire data will be taken through the network to train the model. And batch size 32 means I will update my model after I have taken 32 data points from the network. So epochs is total number of times the model will see the data, but I cannot update my model after every single data point. That will be very challenging computationally, and it will also affect my model by making it slow to learn, because it might go here and there while learning. For example, if one data point or one image is corrupt, that corrupt image will actually lead to a lot of changes in my model that I don't want. That is why I make changes to my model after a certain number of errors have been calculated. So I will take 32 data points through the model. I will calculate the errors that the model has gotten on those 32 points. I will average the error for these 32 points and then use that error to tune my model, to update my model's learning. Okay. So I have just run the entire thing here. Okay. In this entire, in this entire loop, number of epochs, I am training my model. First, I am shuffling my data. Then I am taking the states and targets. And then I am training with respect to batches. So I'm taking batch 1. Then I'm taking the target for the batch 1. Then I am running it through the model. I am calculating the loss. I am optimizing my model. which is basically I'm backward propagating the error so that my model weights and biases are updated. And then I'm going to the next step. So just like that, my model keeps getting better and better and better. The performance of my model keeps on increasing after every epoch, right? You can see, I have to scroll down a lot. Then I pick up my test data. Okay. And on my test data, I evaluate the performance. I get some output from the model. And then I calculate simple accuracy metric on out of how many times when my actual data said stop or go, did my model predict stop or go? Okay, so I'm getting with a very simple implementation, minor data set, minor training, no need of GPUs, no large parameters, very small model. Just to show you guys an example, I was able to get an accuracy of 71%. If I do more training, if I get more quality data, if I add more layers, increase the complexity of my model, I can increase the accuracy. Because again, it's a matter of life and death. Am I clear, everyone? This notebook will be shared with you. Don't worry. Okay. Does anyone have any questions? That was the end of today's webinar. Any questions, please let me know. Also, please fill the feedback form that has been shared with you on the chat. Feedback helps us understand if you are able to grasp the concepts, understand the logic, and what more webinars or topics would you like to learn? I open the forum now for any questions. We have 10 minutes for Q&A. Nutan, you will get the code. Don't worry. The code and the PPT will be shared with you. I think you will have to register on the link, actually pass your feedback. And from the feedback, we'll be getting your email ID and we will be sharing all the content of today's webinar on that email ID. Okay. If you fill the form, I think the form will ask for your email ID. There we can send you the code and everything. Any other questions? Sir, how can we teach initial data analysis things to special need students? Okay. That's a very interesting question. That's actually first time someone has asked a question like this to me. See, initial data analysis should not be programmatic or Excel or SQL or any tool based. It should be very reasoning and logic based. For example, if you tell anyone that I know across India, what is the sales of some product, let's say Maggi, across India, then ask them to analyze Maggi's sales across India. So instead of using Excel or Python or SQL or anything, the first thing that you should be considering teaching them is the ability to ask the right questions. Can they, suppose, they will say that I will find out the state with the highest sales, I will find out the sales with the least sales. Then you will have to immediately ask them, do you think just the sales number is ample to show the quality of Maggi sales in that state? Then the human mind, being as creative as it is, they will ask, no, it depends on the population on that state. So you will actually have to go and find another metric that, verbally, you can find out the metric. It is sales per unit of population. Sales per human being in that state. Right? Then you will compare a value. So instead of teaching someone a tool first, what we do at Ivy is that we first make sure that they have the ability to ask the right questions. If they don't have that ability, no matter what data you give them, they will not be able to do any analytics. So I will definitely ask you to first increase the curiosity in them to ask the right questions from data. And when they have to ask the right questions from the data, when they already know, they will already understand the need of tools to answer those questions. Then you can teach them the tools. This has to be done by domain, right? Teach them about supply chain, healthcare, finance, retail, etc., etc. So that's something that I can think of as of now. I want to know that will the AI take over jobs and make us jobless, because we see that AI is replacing humans by performing accurate in many works and also by giving answers. See, it's like the transformation from industrialization to technology, right? There was a time when the labor at all industries in the world were only humans. There was no machines. But then industrialization came in, machines came in. So a lot of jobs for human labor were lost. But a lot of jobs were created also, right, for technology. Who knew that something like AI or programming could actually do so much value addition to human lives? 20 years, 30 years before, nobody even thought this might be coming, right? So it is basically, a world or a universal thing that every time old jobs are removed, new jobs are created. That is why at any point of time, you should always be thinking of upskilling yourself. Okay, upskilling yourself is the most important challenge of human lives, be it in terms of health, in terms of knowledge, in terms of skill set, tools, whatever. Try to upskill yourself so that you are adaptable to the changes in the larger industry. Okay, I hope that answers your question. To give a very simplistic answer, no, jobs will not, nobody will be jobless, but yes, if you don't upskill yourself, you will be meaningless in a few years. Okay, you have to add value to whatever organization you are working for. Is maths necessary for data science? Not the kind of maths that gives you the chills, more of the logical math, right? For example, if you have 10 numbers, if you have a friend circle of 10 people, and I want to know if people in your friend circle are tall or short, how would I find that out? Some person in your friend circle might be tall, some person in your friend circle might be short. So what I would do is I would find out the average height of your friend circle. And depending on the average height of the friend circle, I will comment if the height is tall or short of the entire group. Okay. A similar thing can be applied when I have to compare the average height of your friend circle to the average height of the country. Because there are countries which are genetically short, there are countries which are genetically tall. Right? So I will compare your group's average with the national average to see if you are taller than normal, average human being in that country, or if you're shorter than them. Then it could be based on gender, right? So that kind of math where you understand summarizing numbers, evaluating answers, analyzing digits, like that. Okay, great. What are the skills that you want us to learn so that we adapt to any job and move on with it? First of all, you have to learn AI, right? You have to understand AI, starting from tools like Python, right? Then machine learning, data science, AI, definitely learn those. That will set you apart from a lot of the population and a lot of competition that you get in the job market, right? Suppose you are an expert in finance, you have an MBA in finance. There are a lot of MBAs in finance, but how many MBAs in finance are AI professionals? Because now they will combine the fields of finance and the field of AI together to create the next generation, next cutting edge product or technology, right? So definitely you should start with data science and AI. Great. Thank you everyone for joining this webinar today. I hope to see you all in class. Have a great day. Thank you so much.